Hello everyone. Today I'll discuss about molarity, normality, and dilution law. So, what are these terms? Molarity, normality. These are basically to quantify the solution's concentration. So, we define these terms to basically understand the concentration of solution. Molarity, if we say talk about molarity is number of moles of solute per liter in a liter of solution. So molarity, capital M, is moles of solute present in volume of solution, volume of solution, basically of solution in liter. So when we try to define the concentration in terms of molarity, it deals in number of moles of solute. But when we see some reaction, for example, let's talk about a reaction of HCl with NaOH, which will form NaCl plus water. So if we talk in terms of moles, it will say that 1 mole of HCl will react with 1 mole of NaOH. Well and good. But if we take another example, H2SO4 plus 2 NaOH will give Na2SO4 plus 2H2O. So if we see now 1 mole of H2SO4 will react with 2 mole of NaOH. Now if we discuss the concentration of solute in terms of molarity or moles, 1 mole of H2SO4 will react with 2 moles of NaOH. So what we can understand here, that there is something different between HCl and H2SO4, that is reactive power basically, or we call it N factor, because H2SO4 gives 2H plus per molecule and HCl gives 1H plus per molecule. So we define term like N factor here, where H2SO4, as it gives 2H plus 1 molecule, so its N factor is 2. And for HCl, it gives 1H plus, so its N factor is 1. Basically what we are trying to say, that it has more reactive power, H2SO4, to neutralize NaOH. So that's why only half mole of H2SO4 is required to neutralize 1 mole of NaOH. And if we can find some terms where equal number of unit is interacting with each other, it will be easier for us to calculate, to understand the reaction. So here it can be said that half mole, it means 1 gram equivalent of H2SO4 is neutralizing 1 gram equivalent of NaOH. So 1 gram equivalent of H2SO4 is neutralizing 1 gram equivalent of NaOH. So basically gram equivalents are defined as moles into N factor. So half, like here, half moles of H2SO4 was neutralizing 1 mole, so it is 1 gram equivalent of H2SO4 is neutralizing 1 gram equivalent of NaOH. So basically N factor, let's understand N factor more. So for acids, number of OH, number of H plus one molecule, and the number of H plus a molecule of acid can furnish, it is called N factor. It's called N factor. For base, number of OH minus a molecule of base can furnish is called N factor. And for redox reaction, number of electron transferred is termed as N factor of that reactant. I hope this N factor is clear. So why we have introduced this N factor? To reduce the overhead of balancing the reaction, because earlier when we are trying to see any of such reaction, we always need to know the balanced reaction. But when we talk in terms of gram equivalents, so it will always equal gram equivalent, 1 gram equivalent of both NaOH and H2SO4 is reacting. So we do not need to know the balanced reaction. We can just calculate the gram equivalents of H2SO4 and gram equivalent of NaOH. So equal gram equivalents will react to each other. So for this new concentration term, normality was introduced. Normality of solution is defined as, it is represented at capital N, and it is defined as number of gram equivalents of solute divided by volume of solution in liter. Now let us see how we calculate these gram equivalents. So there is one more term I would like to introduce here, equivalent weight. Weight equal to molar mass divided by N factor, and gram equivalents equal to mass of solute divided by equivalent weight. So mass of solute, equivalent weight we have already defined, molar mass, and N factor will go up. So this is nothing but moles, number of moles into N factor. So normality as we define as number of gram equivalents of solute divided by volume of solution in liter. It can be written as moles, number of moles of solute into N factor divided by volume of solution in liter. So it will give us this term gives us molarity. This is the relation between molarity and normality. So basically these are the terms we can define to understand the concentration of solution. Now now we will discuss about dilution law. So what dilution law says that when a solution is diluted, the number of moles or gram equivalents remains constant over dilution. So if we see suppose I will talk at the same time, I will take an example also. So if we take some solute here, it is some solute is dissolved in a solution, say 2n. Now initial concentration, pot 1, initial concentration of HCl is 2n and 100 ml volume, in 100 ml volume. So we will understand dilution law, and simultaneously we will understand in terms of calculations also. So now this solution is diluted with and made it to 500 ml. The same solution is diluted to 500 ml. Now we have only added water to dilute it, but the number of moles of solute which were dissolved have not changed. So number of moles of solute or gram equivalents of solute are constant over dilution. This has not changed. So if we see gram equivalents, normality is gram equivalents upon volume. So if we see pot 1 initial state, suppose we say N1 was the concentration and gram equivalents of solute is not changed here, divided by V1 was the volume. So now earlier state, gram equivalents of solute would be N1 into V1. This has not changed, this is constant, and this would be N2 V2 of after dilution. Similarly we can calculate gram equivalents of after dilution would be N2 V2, so it is equal. This gives us law of dilution, that N1 V1 equal to N2 V2. And to solve this, like we said that at first stage 2n HCl 100 ml volume is diluted to, suppose say N2 some normality and 500 ml volume. So we can calculate that N1 with N1 V1 equal to N2 V2. We can calculate 2 into 100 equal to N2 into 500, and it will give us 2 upon 5, it is 0.4 N. So after dilution, the normality of solution would be 0.4 N. With this, I will stop here, and I hope you would have understood molarity and normality and dilution law. I'll continue with other topics in next video.